do the continuation of number plane, which in all the senior years, 9, 10, 11 and 12, is called coordinate geometry or linear relationships. There are 11 main rules for this entire topic, and as long as you know how to use those rules and when to use those rules, you should have absolutely no problems. It's quite an easy topic really, once we get a hang of the rules. So these are our 11 rules. Make sure that you either copy them down or you take a photo or print them out so that you can work with those next to you while we continue through the next few videos. Knowing when to use these 11 rules is going to be crucial to whether or not you find this topic very difficult or doable and relatively simple. The first two rules I'd like to go through are the distance formula and the midpoint formula. The first rule I'd like to go through is the distance formula. Although the distance formula actually looks quite complicated, you really should already know how to find the distance between 2 points using Pythagoras. Let's have a look. If I have 2 points, 2, 8 and -1, 2. I'd like to find the distance between these 2 points. Of course, I could label the 2 points x1, y1 and x2, y2, and I could just substitute them into the formula. But let's try to understand where the formula comes from, because it is a very complicated formula, and if we can figure out a way to remember it more easily, then that'd be great. So I'm going to draw a triangle here. I draw a horizontal line from this point, and I draw a vertical line from this point. And because we've drawn a horizontal and vertical line, we've actually created a right angled triangle. We know that we should be using Pythagoras. Our distance between our 2 points, if I call them A and B, the distance between A and B is the hypotenuse. I know that c squared equals a squared plus b squared. That's our rule for Pythagoras. So ab squared equals that squared plus that squared. And what are those lengths? This point here is at 8 and this point down here is at 2. So the distance between 8 and 2 will be 6. And the distance over here, this one's a bit tricky, it's going to be between -1 and 2. So the distance between -1 and 2 will be 3. So if we use Pythagoras, we would have ab squared equals 3 squared plus 6 squared, which is 9 plus 36, 45. That's ab squared. So ab equals the square root of 45, which depending on if you've done surds or not, you would either leave your answer as a decimal, or you would say that's the square root of 9 times 5, because 9 times 5 is 45, and then the square root of 9 is 3. And that's the exact length of the interval joining A and B. Of course, we could have just used our formula. If we substitute just straight into the formula, and there's nothing wrong with doing that, then what would I have had? I can come over here and do exactly the same thing just by substituting into the formula. My 2 points are A is -1, 2, and my point B is 2, 8. Let's substitute straight into the formula without using the picture at all. I name my points x1, y1 and x2, y2. It doesn't matter which one is x1, y1 and which one is x2, y2. It doesn't make any difference, just as long as the x1 and the y1 go in one point and the x2 and y2 go with another point. I then have my rule. I don't need to rewrite it because it's just there. And I just have to make sure that I substitute in the right numbers in the right spot. So y2 minus y1 squared plus x2 minus x1 squared. And then I just have to add my numbers. 8 take away 2 is 6. 2 minus 1 is 3. And you should see that by doing those subtractions, y2 minus y1 and x2 minus x1, really all we've done is found these distances here, 6 and 3. 6 squared plus 3 squared, and of course we need to square root it to get the hypotenuse. And that's all we've done over here. So that'll be the square root of 45, which again, if I leave it in exact form, would be the square root of 9 times the square root of 5, which is 3 root 5. So if we're given 2 points and we're trying to find the distance between them, we can either draw a picture and use Pythagoras, or we can just use the formula. Some of you might be thinking, well, why would I need the formula if all I need to do is use Pythagoras? It's not always the quickest method to have to draw the diagram and to figure out the distances for these lengths. It's much quicker to use the formula. If you're a student that wants to do your work quickly and accurately, then you really want to know the formula, because that's going to be the quickest method, unless of course you already have the diagram in front of you. But if you're struggling a little bit, then you might actually find, well, you might not be able to remember that formula. So you might find that it's much easier just to draw the picture every single time, just a quick little sketch, and then use Pythagoras. And there's nothing wrong with that. So that should have been relatively easy. Let's just do one more to make sure that everybody understands. And I'll do it both ways, once using the formula and once using Pythagoras. This time, I'll start by using the formula. We're going to have 2 points and we need to find the distance between them. So we have 2 points, A and B, and we want to find the distance between them. We call this one x1, y1, and let's call this one x2, y2. Remember, it doesn't matter which one's which, as long as the x1, y1 go together and the x2, y2 go together. I'm going to use the formula first. So I have the formula already written up there. If you didn't have the formula at the top of the page, then you would need to write down the formula. And all I need to do is to sub in the numbers into the right spot. So y2 is -3, minus y1 is 5, all squared, plus x2 is -2, minus x1, which is 1, all squared. And then I just need to work them out. -3 minus 5 is -8 squared, plus -2 minus 1 is -3 squared. And hopefully we all know how to square a number. 64 plus 9. You could just do this bit on your calculator, which is going to be the square root of 73, which doesn't simplify. So I either leave my answer in exact form, which is the square root of 73, or if it asks you to leave your answer to 1 or 2 decimal places, then you would use the calculator. Now let's do the same question, except this time we're going to use Pythagoras. So I want to plot my points. 1, 5 will be up there, and -2, -3 will be over there. I want to find the distance between them, so I need to join them up with a ruler. Make sure you're using a ruler, otherwise it makes everything a little bit more difficult. We need to draw a horizontal line and a vertical line. And I should point out that if you wanted to draw your horizontal and vertical line up here, you could draw your horizontal line there and your vertical line over here, and that's perfectly fine. You would just have your right angle triangle up there instead of down there. Makes no difference. I'm going to use the black one, but if you prefer the one in red, go for it, use the one in red. I'll just leave it there for the moment. I now need to find the distance between A and B. So I need to find the length of this line, which is from 5 to -3, which is 8. Be careful of the minuses. And the distance between -2 and 1 is 3. And then I can use Pythagoras. C squared equals A squared plus B squared. 8 squared plus 3 squared, which of course are the same numbers that we got in there. 64 plus 9. So C squared equals 73. and c equals the square root of 73. And of course I would be in really big trouble if my answer using Pythagoras was not the same as my answer using the formula. So that's a good way to always check your work if you have time at the end of the exam and you want to make sure that you're getting everything correct. Here's two more questions on distance. Here's two more questions on the distance formula that you need to just be careful. Let's say that you have the points 1, 3 and negative 2, 3. Of course, we could just use the distance formula and sub it in very quickly. Let's have a look. The distance formula says the square root of y2 minus y1 plus x2 minus x1 and then I would label my points and substitute it in. We'll just do it very quickly. Equals the square root of 9, which is 3. So we know that the distance is 3. We can always use the distance formula. But if you were observant, you might have noticed that the y values here were the same. And if the y values are the same, what does that actually mean? That means that our points 1, 3 and negative 2, 3 are actually on a horizontal line. And of course, if they're on a horizontal line, we should be able to find the distance between those 2 points just by looking at that distance there, which is just 2 plus 1. So in actual fact, if you're observant and you notice before you use the distance formula that these 2 points were on a horizontal line, it would be really easy to just do 2 plus 1 is 3. But again, there's nothing wrong with not realizing, using the distance formula and getting the answer as 3. Of course, there's nothing wrong if you get the question right. If we have a look at number 2, now that I've already done number 1, I would think that everybody's going to notice now that the x values of this point are the same. And if the x values are the same, then that's going to make our points on a vertical line. So we can also plot those. 5, negative 1, let's say is over there. 5, negative 1, and 5, 4 will be up there. And if I join these up with a straight line, that's negative 1 and that's 4. If I wanted to find the distance between these two, I would just go 4 plus 1 is 5. So I would know that the distance here is 5 without using the formula at all. But like I said, if you don't realise and you don't have a diagram, using the formula is fine. Our second formula is the midpoint formula. The midpoint formula will give us the middle of 2 points. And how do we find the middle of any 2 numbers? We find the average. And that's exactly what the midpoint formula is. It's the average of the x's and the average of the y's. x1 plus x2 on 2, average of the x's, and y1 plus y2, the average of the y's. There's only 2 styles of questions that you can really be asked. One is very basic and the other is a little bit more tricky. So let's have a look. Type 1 will just be find the midpoint of 2 points. So let's say we have the points A, 1, 5 and B, negative 2, 6. If I need to find the midpoint of these, of course, I have my rule. I need to label them x1, y1 and x2, y2. But we know from the last formula that it doesn't matter which one's x1, y1 and which one's x2, y2 as long as we keep the 1's together and the 2's together. So we have our formula, it's just up there. We're going to sub in the numbers exactly where they go. x1 plus x2 on 2, comma, y1 plus y2 on 2. And then we have 1 take away 2 is minus 1 over 2. And 5 plus 6 is 11 over 2. If you prefer to write that as 5.5, that's fine, but you don't have to. Just an extra place to make a mistake. leave it as an improper fraction, unless you need to plot it on a number plane, in which case it would be easier to think of it as being 5.5. So the second type of question that we can get that involves midpoint is one that looks like this. The midpoint of an interval AB is 3, 1. If the midpoint A is 5, 8, what are the coordinates of B? I'm going to sketch it just so that we have a quick idea of, just so that we have a better idea of what's going on. I'm not even going to use a ruler. I just want to have a rough idea of what I'm trying to actually do. I need to plot my points, A, B, and the midpoint. A is 5, 8, that's somewhere over here. I know that the midpoint is 3, -1, that'll be somewhere down there. And I know that that point there is the midpoint of my line AB. So B is going to be over here somewhere. It's asking me to find the other end point. They've already given me the midpoint. Now remember, as soon as you see a question that's asking you about midpoint, you should be able to write down the midpoint formula. x1 plus x2 over 2 and y1 plus y2 over 2. We can now substitute everything we know into the formula. We know that this point here is the midpoint, so that point goes over there. That's actually the answer. We're going to be working backwards. We know that this point here could be x1, y1, and our point B would be x2, y2. I need to put in all the numbers where they belong. x1 is 5, x2 I don't know, that's what I'm trying to find. y1 is 8, and y2 I'm trying to find. Now this is where this question gets a little bit complicated. If I know that that point there has to equal this coordinate over here, they're supposed to be equal. This is the midpoint, but that is the midpoint as well. So if these are equal, don't I know that this part here has to equal that there? And I know that the second value, the y value of the midpoint, has to equal this, which is the y value of the midpoint. And if I understand that, surely I can then say, okay, so if 3 equals 5 plus x2 over 2, I can now solve that equation to find the value of x2. Times both sides by 2, and I get 6 equals 5 plus x2. Take away the 5, and I'm left with x2 equals 1. And if I do the same thing over here, I have minus 1 equals 8 plus y2 over 2, times both sides by 2, negative 2 equals 8 plus y2, and take away the 8, so that y2 equals minus 10. I now know that the coordinates of my point B must be 1, negative 10. And of course my diagram's not 100% accurate, but I never said it was going to be accurate. I just wanted to have a rough idea of what was going on so that I knew what to do in the question. Thanks again for watching the videos. Don't forget to share, like and subscribe below. See you next time for more.